We're going to be dealing with exponential models today, notes 52. So let's say you invest $1,000 in a bank and received 1.5% interest compounded annually. So you're going to be given an exponential model of y equals a times the quantity 1 plus r raised to the t power. So y is equal to the total amount at any given time t, where a, which in this situation is the beginning amount of $1,000. R is the interest rate. You need to make sure that you change the interest rate from percents to decimals. So remember up here, if you have 1.5%, when you drop the percent sign, you move the decimal 2 places to the left because percent means per 100. So this would represent 0.015. And then the growth factor is 1 plus the rate. So it'd be 1 plus 0.015, which is 1.015. And then t is the number of years compounded. It could be months also. In this particular problem, it's actually years because annually means years. So the equation will look like y equals 1,000 times the quantity 1.015 raised to the t. So how many years will it be until it doubles? Well, if we go ahead and put this in and then make a table of values if we raise this to the 10th year, it will be $1,160.50. For 20 years, it would be $1,346.90. And then for 30 years, it's $1,563.10. So you can see that it's gone up, a little less than $200 every 10 years. So you want it to double, which means to go from 1,000, basically we need this figure right here to be at 2,000. So, if you're thinking of it, for like year 40, just on the estimate, that would be like $1,763, something like that. Okay, because if we do every 200. So at 50, it'd probably be a little more than 2,000. So anyways, if you continue with this table, you can look and see, if you put this equation in, that at year 47, it would double from 1,000 to 3,000 or to 2,000. Number 2, a national forest consisting of 20,000 acres has been declining at a rate of 1% per year. So our A is going to be the 20,000 because that's the beginning amount. The R, remember, the rate rounded to a decimal. So if it doesn't have a decimal, it's understood to be to the right. So we drop the percent, move it 2 places to the left. So this would be 0.01. And then 1 minus R. So this would be 1 minus 0.01. So 1 minus a penny, $1 minus a penny is 99 cents. So this is 99 cents. And this will be our decay factor. Instead of our growth, because it's not growing, it's not over 1. This is going to be less than 1. So this is our decay factor. So at 10 years, it's going to be 18,088. 20 years, it'll be 16,358. At 30 years, it's 14,794. So the equation would look like y equals 20,000 times the quantity, 0.99 raised to the t power. So about how many years until the forest will be half of its original size? If you scroll on your table, after you put that equation in, it would be about 68. All right, let's take a look at problem 3. A town had a music festival for the first time with 150,000 people attending. Wouldn't that be nice? Maybe after this pandemic, we'll be able to get back to that. The attendance is expected to increase by 8.5% each year. So on A, the beginning amount is your 150,000. The rate, remember we have to convert this, so 8.5%, drop the percent, move the decimal 2 places to the left, so that's 0.085. And then the rate, because it is increasing, be 1 plus 0.085, which is 1.085. That's your growth rate. So write an exponential function. So y is equal to 150,000 times the quantity 1.085 raised to the t power. How many people will attend the festival? In the 5th year, round to the nearest 1,000. So this would be about 226,000. All right, number 4. A website has 500,000 members in 2010. The number of members increased by 15% each year. Write a function for this. So it'd be y equals 500,000 is your beginning amount times the quantity 1 plus, so 15% as a decimal is 0.15, so it'll be 1.15 raised to the t years. How many members will there be in 2016? So round to the nearest 10,000. So remember, if this is in 2010, so in 2016, you want this t right here to be basically to the 6th power. Or you can just put that whole equation in your graphing area and create a table and scroll down to in 6 years. So your exponent will be the number of years since 2010. So this would be 1.16 times 10 to the 6th power, which is round to the nearest 10,000. So this will be 1,160,000. All right, number 5, a value of a car. So this is real applicable, especially to you freshmen who are going to be driving if you're not driving already. The value of a car is $21,500. It loses 12% of its value every year. This is called depreciation. So y equals, this is a decay, a times 1 minus r raised to the t power. Write a function modeling this situation. So y equals the beginning amount, and this will be 1 minus 12%. So basically, I shouldn't have put that. Let me erase that because we want to put what it is. Now, could you put 1 minus 0.12 in there in the parenthesis and get the calculator to basically calculate that $1 minus 12 cents is 88 cents? Yes, you could. How much would the car be worth in 6 years? So it would be worth $9,984.70. So that's quite a bit of depreciation. Number 6, a particular insect population triples in size for several years. So a particular insect triples in size for several years. Write a function to determine the number of insects 6 years from now if the initial insect population was 1,200. So on this one, let's see, we have y equals, the initial amount is 1,200, and then triples in size. So that's 3 times 3 and then raised to the 6th power. Number 7, there are a total of 256 teams in sport. 1/2 of them are eliminated. So half of them are eliminated. So y equals 256 times 1/2, and let's go ahead and just put that in parentheses, raised to the 5th power. Number 8, an indoor water park had a declining attendance from from 2011 to 2016. The attendance in 2011 was 32,000, so that's going to be your beginning amount. And it decreased by each year by 1.5%, which is fine. So you know you begin with 32,000. So remember that 1.5%, drop the percent, move it 2 places to the left. So it's 0.015. All right, so, and it's going to be raised to the 5th year because from 2011 to 2016 is 5 years. All right, so it looks like it is going to be A. Now, they did put 1 minus 0.015, which is okay. So it's not adding, and this is 0.15%. So that would be 15%. So that one's not right. Okay. And then number 9, fast-growing virus has been shown to quadruple. So that's multiplied by 4 in size every hour. If the virus initially measures 22 nanometers, write a function to determine the size of the virus. So you start with 22 times 4 raised to the 7th power. So that is definitely answer choice B.